Hello students, in previous lecture we have studied about the rhombus and properties of rhombus and examples from practice set 5.3 which is related with the properties of rhombus. Then today we are going to learn about the properties of trapezium. One more quadrilateral. It is one of the type of quadrilateral in which one pair of opposite side is parallel to each other. Parallel is called trapezium. Then see here in quadrilateral ABCD, here AB parallel CD and AD and BC sides are non-parallel, and therefore that quadrilateral ABCD is a trapezium. It is a trapezium. Then the properties which is related with that trapezium, we will study about that. Then we will study about the properties of trapezium. Then see here, first of all, only one pair of opposite sides are parallel to each other. And here, see here, as those are parallel to each other, then here considering AB parallel CD and here AD is a transversal, therefore here angle A and angle D are the internal angles, or it is angle A and angle D are the interior angles, therefore sum of those two angles are 180 degree. That means here the angle A plus angle D is 180 degree. That means those angles are supplementary in nature. As well as here AB parallel CD and BC is a transversal, therefore those angles are here, those angles are interior angles, and interior angles are, that is supplementary. Angle B plus angle C is equals to 180 degree. And here one more property which is related with the trapezium, that is, see here, if the midpoints of non-parallel sides, see here AB and CD are parallel to each other, those are the parallel sides, opposite pair of sides, those are the AB parallel to CD, that is the pair of opposite side which is given here in the trapezium, but AD and BC are non-parallel sides, therefore the midpoints of that non-parallel sides, that means here L is a midpoint of side AD and M is a midpoint of side BC. If the midpoints of non-parallel sides, if it is, then the segment which joins, which is passing through the midpoints of non-parallel sides of trapezium, that side is also parallel to AB and CD. That means here, and that segment which is joins to the midpoints of non-parallel sides of trapezium is known as medium. Here the segment which joins to the midpoint of non-parallel lines, non-parallel sides of trapezium, that is a median of that trapezium, and which is also parallel to the, that is parallel sides. That means here AB parallel, LM parallel, CD. Then one more property which is related with the isosceles trapezium. See here, isosceles, that means here the trapezium of which non-parallel sides, when they are congruent, when it is congruent. That means here in quadrilateral ABCD, AB parallel CD and AD and BC are the non-parallel sides of this trapezium, but here AD congruent BC, then it is a isosceles trapezium. And here in isosceles trapezium, that is one pair of opposite sides are parallel, and non-parallel sides are congruent. That means here AD congruent BC, and here one more property which is related with that trapezium, that is here isosceles trapezium. Here that base angles, see here angle D and angle C are base angles of isosceles trapezium are congruent. That means here angle D congruent angle C, and as angle A and angle D are supplementary, as well as angle B and angle C are supplementary, and angle D and angle C are congruent, therefore here angle A congruent angle B, angle A congruent angle B. Then we will solve the examples which is based on those properties of trapezium from practice set 5.4. Few examples which is given here we will solve. Then see here examples from practice set 5.4. One of the example which is given here, that is here ABCD is a trapezium in which here BC parallel AD is given here, as well as here AB congruent CD, and we have to prove that angle ABC congruent angle DCB. Then that property we have to prove here. Then see here, in quadrilateral ABCD, as BC parallel AD and here BC is less than AD and AB congruent CD, therefore quadrilateral ABCD is a isosceles trapezium. It is a isosceles trapezium, and here in isosceles trapezium, that is angle A congruent angle D, because base angles of isosceles trapezium are congruent. Then we already studied about the properties of trapezium, that is, see here, as BC parallel AD and here BA is a transversal, BA is transversal, therefore here angle B plus angle A is equals to 180 degree, that is interior angle theorem. Let this equation 1 as well as here BC parallel AD and transversal CD, then angle D plus angle C is equals to 180 degree. Let this equation number 2, that is interior angle theorem. Then see here, but angle A congruent angle D, because here base angles of isosceles trapezium are congruent, because here the trapezium which is given, that is isosceles trapezium, and property of isosceles trapezium, and here let this equation number 3. Then see here, from equation 1, 2 and 3, from equation 1, 2 and 3, here angle B plus angle A is 180 degree, angle D plus angle C is 180 degree, but here angle A and angle here D are congruent, and therefore here angle B congruent angle C, that is here angle B means angle ABC congruent angle, see here DCB, that is the proof of this example. Then we will solve one more example from practice set 5.4. Then we will solve one more example from practice set 5.4. That is here here quadrilateral IJKL, which is given here, in which angle I, quadrilateral IJKL, is a trapezium. It is a trapezium in which IJ parallel LK, and here angle I, which is given here, that is of 108 degree, 108 degree, and here angle K is 53 degree, angle K is 53 degree. Then we have to find out angle J as well as angle L. Then see here, all of you studied about that. In isosceles trapezium, angle I plus angle L is equals to 180 degree. That is the property of trapezium. Then here angle I, that is of 108 degree, plus angle L is equals to 180 degree. Therefore angle L is equals to 180 minus 108. Therefore angle L is equals to, that is of 72 degree, as well as here angle J plus angle K is equals to 180 degree, because here IJ parallel LK and JK is a transversal. Therefore here angle K is of 53 degree, angle J plus 53 degree is equals to 180 degree. Therefore angle J is equals to 180 degree minus 53 degree. That is angle J is equals to, that is of 27 degree. Therefore angle J is equals to 27 degree. That is about the few examples from practice set 5.4. Then you will solve the remaining examples from practice set 5.4 and do the practice of solving those type of examples from problem set also, which is depends upon the properties of different types of quadrilateral. Then we will study about few more concepts, few theorems which is related with the triangles in next lecture. Thank you.